the way we see it, so 5G network slicing, it really provides the mechanism to define like a set of logical services, and those logical services are sharing the same end-to-end infrastructure. So the whole idea with that end-to-end infrastructure, it could be including all the radios and the data plane, as well as all the control plane. So if you dive a little bit deeper into as a part of the 3GPP specs, if you will, a slice is usually defined by two IDs, right? So one ID is like SST, which is the slice services, where it indicates what the expected network slice behavior is in terms of features and services and all that. So that's one of them. And then number two is what's called SD, as in slice differentiator. And that is an ID that is used to differentiate multiple networks and multiple network slices that have the same behavior. And that's how the kind of slicing is defined and what slicing is at a higher level.
So maybe I can add a little bit more to that. I think let me explore the relationship angle, the relationship between 5G, edge computing, and network slicing. So in my mind, if you look at the B2B space, 5G is the ideal network to connect end devices to edge computing applications. So that is where those two technologies match up. And when it comes to network slicing, if before you had something like network slicing, a lot of industries, what they would do is one workload, one network, another workload, new network. With network slicing, you can have sub-slices like Sunny mentioned, and each sub-slice can have different service level agreements or attributes. And that allows you to mix workloads onto the same network. So you can have end devices that are of different types, edge computing applications that are of different types, going over the same network through network slicing.
Hey, that's interesting, by the way. On that case, one example, without going too much detail and distinguishing who that is, but over many customers that were involved in, specifically the operators and telcos, and as you said, Amar, from that perspective, they build the networks over time, but they're specific network for specific requirement or specific use case, if you will. There are tens of networks, and all of they are kind of looking at consolidating and bringing it down, leveraging some infrastructure that allows the slicing would enable exactly the same thing. So yeah, absolutely. We see that a lot.
So the classical use cases, if you go by the standards, are 3 plus maybe 1. And they are latency sensitive, which is called URLLC, ultra reliable low latency, bandwidth oriented, EMBB, enhanced mobile broadband, and IoT centric, which is machine to machine type communication, MMTC. And I said 3 plus 1 because you also have slices with a security bent. So a lot of the government related work we are seeing, that's on secure slices, extremely secure slices. So you can generally say that these are the 4, and then you mix and match. And that's generally the universe of the types of use cases you'll be supporting with slices. So I gave a very sort of standards oriented answer, and maybe I'll hand over to you, Sunny, to explore some of the other aspects Hema asked for.
Cool. Yeah, actually digging on that a little bit further. So from specific use cases, and I'll also come to how some of the markets are with the VC have developed. But from use cases, I mean, as we hear a fair bit about the smart cities and smart homes and smart factories and all that stuff. I would say where we've seen a significant amount of traction is also the whole industry 4.0, and that area, as we watch, is probably one of the earlier ones to go towards that, right? But having said that, in any and all cases, all of these come together, whether these use cases or massive IoTs or augmented and virtual reality comes up a lot. A lot of people are testing for that, and that reality is also happening. But if I were to double click on the massive IoT use case, right? So now we're going to be able to take the factories that can deploy the Mac host, right? And they'll do the however you want to define the local breakout or what have you. But so think of factory being able to take a Mac host and take that on site. Now all of the IoT devices there, and they have obviously need to communicate with applications, and they have a need to communicate with each other, if you will. And literally there's thousands and thousands of elements in this network. Now, in this case, how are you going to offer and guarantee the low latency communication, right? So in this kind of case, it becomes important that you keep all the traffic that need to be remain local. The MAC will keep the traffic local, while also keep an eye on it. The significant amount of traffic would also have to go through the network further beyond for other requirements and other connectivity, right? What we have seen, we're working with really going back to the Industry 4.0, we're actually working with a number of partners and really coming with a blueprint that can be deployed for the specific use cases where we can call it a stamp it out. It's not as easy as that, obviously not. But the thing is, this kind of reference architectures does and will help. Outside of that, maybe speaking out of turn a little bit, but we also demonstrated with a large telecom service provider. Now it's a public knowledge, so I could share that. We demonstrated that with Telenor, and Telenor would, as an operator, is looking to offer enterprise 5G or private 5G services, and we actually have a full demonstration detail, and that includes 8 different vendors, all running on containerized platform and all that, and this end to end. And in that case, we're creating slice and demonstrating that each slice does not end up affecting the other slice. So not only they had multiple customers per slice, and even per customer, there are multiple slices. Hope that makes sense. But these are real that we've demonstrated out in the field. We actually demonstrated a similar thing with Equinix as well in a webinar where we work together and demonstrating how slicing end to end is delivered. The couple that we demonstrated, one was a defense customer, one was a broadcast radio customer, and both of the requirements in their case were different. And Amar initially referred to the ultra reliable low latency, right? The URL. That's exactly what the requirement was of the defense, where any and all devices would have to have the ultra low latency, and that had to be guaranteed and delivered. Now that cannot be done. That just cannot be done in like one size fits all. So they had to have slice such where this slice is absolutely, no matter what, this low latency guaranteed will be delivered. Whereas the other customer in there had much more of a high data rate requirement. But we needed to make sure, the customer rate from that perspective is, they wanted to make sure the other applications that are high data requirements doesn't kind of creep into taking away from a common infrastructure and compromise on the low latency requirement. And that's exactly what we actually live demonstrated together, where traffic is going up significantly on one side, meanwhile the other side is continue to delivering the low latency without any impact whatsoever. So I guess if I were to summarize kind of stuff, is the way of doing the one size fits all, it doesn't cut it. It cannot deliver that. So that's where people would have to go to something like that. Hope that makes sense.
So maybe I can add to that. I completely agree with that. And one different use case that we are seeing is actually in healthcare. So in healthcare, of course, with 5G, you've heard about these crazy use cases like remote surgery, etc. We don't even have to talk about those. I think those are further out. But just the fact that you may have a doctor at a site who doesn't have the expertise, and you want to pull in another doctor remotely over, say, augmented reality, those use cases are quite doable these days with 5G and network slicing. And again, the slice guarantees a certain level of SLA, no matter what is going on in the other slices. So that's really the value. So if you want to say, let's say 15 milliseconds of low latency for your remote doctor use case, then you are guaranteed that no matter what's going on with the rest of the network.
Take it first, and then maybe
please.
I'll bring it towards the VCO 3.0 at the end, where we talk about what we're doing commonly to the marketplace. But look, I mean, let me go back with a specific example, if I may. We talked about Telenor. We'd already discussed what they really, outside of all these things, 8 different vendors, 8 different solutions, all 5G, working end to end, all in the container, under same kind of control plane function, if you will, and a single plane of gas, if you will. All of that was really, their purpose was meant to show the readiness of these technologies in the marketplace. And we absolutely say from our perspective, to that solution, we delivered the networking portion of it, which is obviously a key part of this thing. We delivered the UPF, which is call it the workhorse of the 5G network, where every traffic, every packet needs to go through that. Actually, that network, by the way, if you don't mind me saying, that network actually won the Glomo Award for the Innovative Network of the Year, or how they phrased it. I'm pretty proud of that. So the reality is there. We are showing interoperability with multiple vendors that's there, right? And then we got to go to the next part of really operationalizing it, right? So I am very confident, not only our technology with multiple partners I've seen, we're out of the POCs and labs. We're out into the field actually carrying customer traffic. That's going on. And that's where I want to end on bringing also the work we're doing at VCO 3.0 together, right? And that's where Amar and I had a chance to first meet, and our companies and all that. And we're doing a lot of work together to really create an end-to-end multi-vendor where customer benefits from all of the above, right? No vendor lock-ins and better pricing and better agility and ability to innovate kind of stuff. Amar, does that make sense? I mean, VCO 3.0 is where we've shown it, and now we're showing it to market as well.
Yeah, and I'm sure we'll certainly talk a lot more about VCO 3.0. Let me just add one more point on the readiness. So I completely agree on this point as well. I think the technology is ready. And what we have found, I mean, my experience and your experiences are probably similar, is markets are never really gated by technology. It's more of the cultural business model, those type of issues. And I think that's sort of where we are at right now. Specifically, Aarna Networks works on the management plane. So my perspective is network slicing from a management point of view. Can we manage all these? Can we create slices? Can we manage them? Can we manage their life cycle, terminate them, optimize them? So we've been working in the open source communities with companies such as China Mobile, Wipro, Tech Mahindra, and the work has been going on for at least a year, maybe a year and a half, on network slicing management. So the implementation that we have through Linux Foundation is completely 3GPP aligned. The management solution is ready. There's always room for improvement. There are things like optimizing slices, using machine learning to sort of optimize slices further. That is pending, but all the nuts and bolts, sort of bread and butter stuff on network slicing is ready. So I think from a technology readiness, I would sort of echo the same thing Sunny mentioned.